Namaste and welcome to another session on operations of algebraic expressions. So far we have covered the operations, that is the addition, subtraction and multiplication on polynomials. Let's start with, or maybe let's recap quickly a quotient law, the laws of indices. So more specifically, quotient law. Quotient law is, remember, a to the power m by a to the power n, which will be a to the power m minus n if m is greater than n. For example, if I have 2 to the power 3 by 2 to the power 1, I have, since my 2 to the power 3 minus 1, since my numerator is more, so I will get 2 to the power 2, which is equal to 4. It can be any exponent, degree basically. So let's say that if I have, in a second case, if I have a to the power m by a to the power n, and if I have, let's say, 2 to the power 3 and 2 to the power 3, then it is 2 to the power 3 minus 3, which is equal to 2 to the power 0. Now 2 to the power 0 is 1. Maybe we will take it up in detail why 2 to the power 0, but just know that, let's say that if I have 2 to the power 3, that is 2 times 2 times 2 divided by 2 to the power 2, that means it is 2. So now I cancel out this 2 and this 2, then what is remaining, what's left out is these 2. So that is why it is 2 to the power 2. And here in this case, 2 to the power 3, so it is 2 to the power 3 is 2 times 2 times 2 by 2 times 2 times 2. So then I cancel out this 2 by 1 common factor. So basically I get 1 by 1, which is nothing but 1. So 2 to the power 0, when I do this method, 2 to the power 0, so that is why I end up with 1. Now the second one, maybe the third one is, if I have 2 to the power 3 and then I have 2 to the power 4, here you see I have 2 times 2 times 2 by 2 times 2 times 2 times 2. So now these 3 2's cancel out. So what I'm left with is 1 by 2. So that is why when in a to the power m by a to the power n, if n is greater than m, then we have m by n, a to the power by n by whatever, 1 by n, sorry. Right? Okay. Let's move on to the next one, the rules of signs. So remember, two positives or negatives give a positive. So that is plus times plus will give me plus. Minus times minus will give me plus. But then the opposites give me negative. Right? Sorry. Yeah. Okay. In arithmetic, if you recall, in arithmetic, if you're doing division, let's say I have 15 divided by 5, you know, so 15 is called as the dividend, 5 is called as a divisor. Basically, what it means is that, if you want to basically translate this statement into English, it says that how many fives are there, how many fives are there in 15, right? Or in other words, 15 is divided into how many fives, or how many parts of 5, right? So this is how you translate that. So here it is 15 divided by 5. So there are basically, three fives in 15. So three whole fives in 15. So that 5 this will give me 15 divided by 5 will give me 5, which is called as a quotient. And my remainder is 0, right? Yeah. So here it is, both are taken as positive numbers. So that is why my quotient is also a positive one. Correct? Yeah. Let's take another one. Here, this is a, let's take example 1. Let's take example 2. Let's say I have 21, negative 21, let's say negative 21 divided by negative 7, right? So I see that both the numbers are negative here. Okay. So my quotient will always be a positive one. So negative 21, sorry, negative 21 by negative 7. And how many negative 7s are there in negative 21? So it will be 3. So it will be a positive 3, right? So here both the numbers are negative. Okay, here both the numbers are negative. And you pretend that both numbers are positive. And when you divide it, 7 times 3, 7 times 3, it will be like 7 times 3 will give you 21, right? And 3 will be always positive because my dividend and divisor both are negative, because this is as per the rules of science, right? Now let's take another example. This is just a quick recap. So I have let's say I have a negative 9, the divisor, divided by positive 3. So here we have a negative number and a positive number. So remember, there can be kind of only 3 signs. So that is like, either plus, or minus, or and then the result will be like minus. So this is minus, this is negative 9 divided by 3, this is positive. So obviously, this has to be a negative one, right? This has to be a negative one. So because 3 times negative 3, right, will give me negative, because plus times minus will give me minus. So this will always be, when we have two different signs and we are dividing it, right, it will, the quotient, the result, the answer will always be a negative one. Got it? Yeah. Negative 3 it is, not 3. Because remember, 3 is a different integer and negative 3 is is a different integer. So it's a different number. So you have to be a bit careful. So 3 is not the answer. Example 4, here I have, let's just take, I have 8 divided by negative 2. So here my divisor is negative. So 8 divided by negative 2. So again, there is positive sign and there is a negative sign. So obviously this has to be minus into minus will give me plus. So two negatives make a positive. So this will be negative 4. It will always be negative 4. Got it? Yeah. And let's take two more examples. Example 5. Here we're going to divide by, let's say, dividing 0. We are dividing 0. Right? So 0 divided by 2 will always be like 2 times what will give you 0. So it is 0. And remember, 0 doesn't have a sign. It's neither positive nor negative, right? So it doesn't matter whether my divisor is a negative one or a positive one. So whether it is 0 divided by negative 3, it will still give me 3. And 0 doesn't have a sign, and the sign of the divisor doesn't matter if we are when we are dividing 0. The last one is uh, dividing 0, right? The when the divisor is 0, okay, 0 divisor, so we can call it as 0 divisor. 0 divisor, that means my divisor, that is my denominator, is 0. So now we have to ask, 0 times what will give me 2? It is undefined, it is not possible. 0 times what will give me 2? We can't find it. There is no value for that. So that is why it is undefined. So we can't have a 0 divisor. Yeah. Okay. Now, with that, preamble or introduction, let's get into the topic of today. That is today's topic. That is division of polynomials. So these are the prerequisites that we need to have before we start the division of polynomials. So now, how is this different in algebra, or how is it different from arithmetic and algebra, dividing the terms? So let's take an example here. Let's say that 12 x to the power 6 divided by 6 x to the power 2, right? So now so this is, we are dividing a monomial, right? So this is, we are dividing a monomial. This is a monomial, and this is a monomial. And we have two numeric coefficients here. So these are the 12 and I have 6, right? So let's group them same like the way we did in multiplication. 12 divided by 6. So first we divide the numeric coefficient and then you divide. You basically multiply, but you also divide the. So it is x times x times x times x times x times x divided by x to the power 2. That is x times x, right? So now 12 divided by 6. So both are positive, right? So it is 6 times 2, correct? 6 times 2 is 12. So the numeric coefficient, the value for that, when I divide the numeric coefficient, I get 2. So here in my literal coefficient, so this gets cancelled, this gets cancelled, this gets cancelled, this gets cancelled, and I'm left with basically 4 x's here. So that is x to the power. So when I multiply it, so I'm multiplying it here. So x to the power 4, right? So when I divide 12x to the power 6 by 6x to the power 2, the quotient, this is my quotient, is this, and my remainder is 0. Got it? This is how we do division. Very simple, not complicated. Okay. So just few things that you need to do. One is that you observe we have a constant here and their sign, right? And both are monomial terms. Okay, the constants here in the algebraic equation here are the term, right? We just use the same rules of division, right? It would have been just 12 divided by 6. So it is 6 times what? 6 times 2 is 12. So this is the quotient that I have got. And then you use the same rules actually for division, the whatever we have used in arithmetic. And then for the loss of exponents, so these are the exponents over here. So x to the power 6 and x to the power 2, we use the loss of exponents. Okay, so more specifically the quotient law, to simplify it further. Okay, let's take another example. I have 36 a to the power 7 divided by negative 12 a to the power 3. Right? So you can convert this into fractional form. So 36 a to the power 7 divided by negative 12 a to the power 3. So now what do? We just group the numeric coefficients, that is 36 divided by negative 12. And then we have a to the power 7 by a to the power 3. So now negative 12. So remember I have a negative 12, and in order to get a positive one, so I have to basically multiply, or my quotient will be negative 3, because negative 12 times negative 3 is equal to positive 36, right? Because two negatives multiplied together, we get a positive. So the quotient is 3. Now e to the power 7. So the simplest way, I mean, I showed you how it is. Y e to the power 7, e to the power y e to the power 7 by e to the power 3 is equal to a 7 minus 3, which is equal to e to the power 4. I showed you a to the power 7 means a times a times a times a times a times a times a. 1, 2, 3, 4, 5, 6, 7 divided by a to the power 3, that is a times a times a. So here I cancel out these, right? 3 a's, and what I'm left with is a times a times a times a, that is a to the power 4, right? So now when I multiply it with negative 3 times a to the power 4, so I get a to the power negative 3 a to the power 4. This is your quotient. And again, your remainder is 0. Remember the Euclid's division lemma? We have, just to recap, or just to do a quick revision, we have a dividend is equal to quotient times divisor plus remainder, right? This is your basically the formula to cross check whether your division is right or not. Okay, so we'll get to that later. Now let's do another one. We have negative 50 a squared b cubed divided by negative 15 e to the power 4 b to the power 2. Yeah. Can you do this? Yeah. Did you get this? Okay. So we group this negative 50 by negative 15. And then we have a squared b cubed by a to the power 4 by b to the power 2. Right? If you want, maybe we can do it like this as well, just for your simplicity's sake, for you to understand this better. So I have a to the power 2 by a to the power 4, and then I have b to the power 3 by b to the power 2, right? So now let's divide each term. Okay, negative 50. So pretend that there is no negative sign. So 50 50 divided by 15, right? So both can be divided by 5. So 5 is the HCF. So when I do that, I get 10 by 3, right? So since both are negative, so this has to be, the quotient has to be positive. So we have 10 by 3 here, the numeric coefficient. Now what about a to the power 2? Let's understand now. A to the power 2 by a to the power 4. Yeah, let's expand this. So a to the power 2 is nothing but a times a. A to the power 4 is a times a times a times a. Right? So these two gets cancelled. So what I'm left with is 1 by a to the power 2. Right? So 1 by a to the power 2. Now the third one is b to the power 3 by b to the power 2, which is nothing but b times b times b by b times b. And now these two b's get cancelled. I'm left with b times b. Now we have to multiply this now. So let me erase this. So in my next step, what is it that I do? So now I have my numerator is 10 times 1 times b by 3 times a squared, which is nothing but 10b by 3a squared. This is your quotient. Correct? Got it? So this is 10b by 3a squared will be your quotient. Okay. Let's go to, so far, remember, we have divided a monomial by another monomial, right? Now let's try, so this is basically, most of the questions come from this area of division of polynomials. So this is where we also do long division. So second category today, the most important one is division of polynomial, a polynomial. Okay. Okay, let's take by a monomial. Let's take this one, and then maybe in the next section we will go to division of a polynomial by a polynomial. Okay. So let's take an example. I think this is example 7 or 8. Okay. So we have 9 a to the power 5 minus 6a to the power 2 divided by 3a squared. Okay, let's do this step by step. Let's try to solve this step by step. Okay, let's understand this bit. We have a monomial we have a binomial in the numerator. Now that is basically two terms that I have, and those two terms have to be divided by 3a squared by a monomial. Whatever the terms that are there, that has to be, that has to be divided. So we're going to divide them individually, right? So we it is like this can be written as 9a to the power 5 divided by 3a squared, and then I have a minus, right? I have a minus 6a squared divided by 3a squared, right? So what is 9? So group them together if you want it. 9 by divided by 3, and then a to the power 5 by a to the power 2, then minus, then 6 divided by 3 times a to the power 2 by a to the power 2. Okay, so 9 divided by 3 is 3. A to the power 5 divided by a to the power 2 is a to the power 3. I have the negative sign. 6 divided by 3 is 2. A to the power 2 by a to the power 2 is basically 1, because a times a divided by a times a, this will give me 1, because when we take a common factor, we cancel it out, so it is 1. So when I multiply it by 2 times 1, it is nothing but a to the power 3 minus 2. This is my quotient. Yeah, got it? Yeah. Okay, let's do another one. One example 9. Okay, I want you to try this out. 63 a to the power 4 b to the power 5 c to the power 6 divided by negative 9 a to the power 2 b to the power 4 c to the power 3. Go back, divide the way I have done. Try it. Okay, let's do this. 63 divided by negative 9, then a to the power 4 by a to the power 2, b to the power 5 by b to the power 4, c to the power 6 by c to the power 3. I have a negative, okay, denominator or a divisor. So negative 9 times what will give me 63. So it has to be negative 7. Correct? Now a to the power 4, that is 4 minus 2 is a to the power 2. B to the power 5 divided by b to the power 4 will give me b. B to the power 1 is nothing but 1. That is, the power 1 is, it's b itself. Then I have c to the power 6 by c to the power 3 will be c to the power 3. This is my quotient. Got it? Yeah, correct. Okay, let's do another example. I have 15. Try this. Try, keep writing, keep your, uh, do all mathematics is, we have to practice mathematics. It is not read, but it is practiced. So please practice. Please write. The more you write, the more you practice. It becomes a habit. So 15 a to the power 3 b to the power 4 minus 10 a to the power 4 b to the power 3 minus 25 a to the power 3 b to the power 6 and divided by negative 5 a to the power 3 b to the power 2. Okay. Remember, the terms in the numerator, they have to be divided individually by the divisor. So it will be like 15 a to the power 3 b to the power 4 divided by negative 5 a to the power 3 b to the power 2 minus 10 a to the power 4 b to the power 3 by minus 5 a to the power 3 b to the power 2 minus 25 a to the power 3 b to the power 6 by negative a to the power 3 b to the power 2. Okay, let's do this quickly, right? So I have a negative 3. Now a gets cancelled out because a to the power 3 minus a to the power 3 will give me 0, so that is 1. Now b to the power 4, so it will be b to the power 2, right? So then I have a minus sign over here. Okay, so it is 2 a b. Then I have a negative, so it is again 5 b to the power 4. This is your quotient. Got it? Yeah. But you have a negative sign in the middle. So remember, it is right. So this will be your um, um, the quotient, and maybe we will end it here. Today's class. We'll meet in the class. Okay. Take care. Have a good day. Bye.